Okay, welcome back. In the previous video, we implemented the ability for interping the weapon so that it flies up right in front of the camera just before we swap the weapons. Now we saw, however, that there was an issue with rotation. If we go ahead and pick up a weapon and then we rotate rapidly, we'll see that it looks like the weapon itself is rotating. And that's because the weapon is keeping its own rotation constant. The weapon is not rotating along with the camera. So if I pick up a weapon and rotate rapidly, you can see this. So I'm going to do that here. See how the weapon rotated as I was turning around. And so we would like that weapon to rotate with us so that it doesn't appear to be spinning. We want it to appear to keep its rotation relative to the camera. So we're going to do that in this video. Now, the way we're going to achieve this can be described as follows. Let's say we're looking straight down at the floor in the negative z direction. This means we're looking down on the xy plane. Now say we have our camera in the world and our item is also in the world, and our camera has its own forward direction. And the item has its own forward direction, which is very likely different than our camera's forward direction. So this means that our camera has its own rotation. And if we're only considering rotation in the xy plane, basically the rotation about the z-axis, that's the yaw component of the rotation. So our camera has its own yaw, and our item in question also has its own yaw. And so at the time when the interpolation timer starts, both of these objects have a yaw relative to each other. Now here I have the camera's forward vector and the item's forward vector placed such that their tails are touching. In other words, they each have a yaw, and the difference between their yaw values we can call the yaw offset. Now we can calculate this yaw offset by taking the item yaw and subtracting the camera yaw, and that will give us the yaw that is the difference between the item and the camera. Now our goal should be to keep this yaw offset constant. In other words, whenever the camera rotates, we would like our item to rotate exactly that same amount so that its yaw difference from the camera is the same as that initial yaw offset. So the more the camera rotates, the more the item rotates along with the camera. We can achieve this by each frame setting the yaw of the item equal to the yaw of the camera plus that yaw offset. So it will always be equal to the camera yaw plus that yaw rotation that is the difference between the camera and the item. So we're going to do that now. So we're here in item.h, and we're going to add a couple of private variables here just at the bottom of the private variables section. The first is going to be a float, and we're going to call this interp initial yaw offset. Now I'm going to give this a comment so we know what we're talking about here. And this is the initial yaw offset between the camera and the interping item. Now we can give this a default value in the constructor for item.cpp. So let's come up here to the constructor in the member initializer list. We're going to say interp initial yaw offset can have a default value of 0.f. Now where we're going to give this an actual meaningful value is in the start item curve function. So here in start item curve, down at the bottom, I'm going to create a const float and call this camera rotation yaw. And I'm going to initialize this with character, and from character I'm going to get the follow camera with get follow camera, and from the camera I'm going to get component rotation, and from get component rotation I'm going to get the yaw component, and that gives us the yaw component of the character's follow camera component. Now we get a squiggly line because we're including the uCamera component, so we need the include for that. So in shooter character.cpp up at the top we can get that include. right here it's camera/camera component. Copy that, and at the top of item.cpp, we can include that. So now we have our camera's rotation yaw at the point in time when we called start item curve. We're also going to want another const float local variable. So const float, and this one will be the item rotation yaw. Now this one is going to be the yaw of the item itself. So we can simply call getActorRotation, and we can get that yaw component of that rotation. So here we're getting the initial yaw of the camera. So let's comment and say get initial yaw of the camera. And then here we're getting the initial yaw of the item. So get initial yaw of the item. And now finally, we can set our value for the variable we just created called interp initial yaw offset. So down here, we'll use interp initial yaw offset and set that equal to the difference between these two floats. It's going to be item rotation yaw minus camera rotation yaw. And this will be that difference in yaw that we were talking about in our slide. So this is going to be the initial yaw offset between camera and item. And so this is what we're going to use to keep that constant offset while we're interping. So let's go ahead and do that in our item interp function. So up here in item interp, we can do this down towards the bottom. After we've set our actor location, what we can do is we can first get our camera rotation this frame. So this will be a const f rotator, and this will be called camera rotation. And what we can initialize this to is we can get the character, we can get the follow camera. From the follow camera, we can use get component rotation. This gets us the rotation of the camera. Now we're going to create an F rotator called item rotation, and this will be the rotation that we're going to set for our item this frame. Now we're going to initialize this with our pitch and roll values of 0. So we're going to have 0 for pitch and roll, but the middle value, which is the yaw, is going to be camera rotation.yaw plus that offset, which was interp initial offset. And then finally the roll is going to be 0.f. So this is how we're going to initialize this. And it looks like I must have spelled this wrong. It's interp initial yaw offset, not interp initial offset. So if I spell that correctly, now we have our item rotation. So for this const f rotator, it's the camera rotation this frame. And for this rotator, the comment will say camera rotation plus initial yaw offset. And now we can simply set the actor rotation to this item rotation for the item. So set actor rotation, and it's going to be item rotation. And we can specify the teleport type. We're going to use teleport type teleport physics. So that way we're rotating with teleportation. Okay, so let's compile this and we can test it out. Okay, we're back in the editor and we're going to pick up an item, and the first thing I'm going to do is spin rapidly and see if the item maintains its rotation relative to the camera. So here we go, and there we have it. It's pretty quick. It's a little hard to see, so I'm going to go to second viewport, and I'm going to go ahead and do the same thing. I'm going to pick up the item and rotate rapidly, and you can see that it maintains its orientation relative to the camera. And the cool thing is it keeps its initial rotation. So right here, if I'm looking at this weapon, it looks like it's got this rotation. It's almost like I'm looking at it from the back, so it looks very long and thin. And if I hit the E key and rotate, you'll see that it maintains that initial rotation. And it kind of does that for the orientation that it's pointing in whenever I pick up the weapon. It keeps that orientation, which is the effect that I was intending to have. So So that looks great. So that is going to conclude this video. In the next video, we're going to give this a little bit more of an effect by scaling the item. So as soon as we start the interpolation, once it starts falling down and getting close to the point where we do the weapon swap, I want it to scale down in size so it looks like it's shrinking. So we're going to do that in the next video.